down, let's go back and look at this one more time. Alright, the initial x position is x equal to 2, y equal to 1. There it is. X equal to 2, y equal to 1. That is the initial position. And after 5 seconds, where is the object? The final position is x equal to 8, y equal to 5 is over here. So the change in the x position is delta x equal to 8 meter minus 2 meter is 6 meter I. That is the change in the x position. Delta x equal to 6 meter I. And change in the y position is delta y equal to 5 meter minus 1 meter. That will be 4 meter j. And that is for delta y equal to 4 meter j. V average in the x direction is delta x over delta t, which is 6 meter divided by 5 seconds, which is 6 over 5 meter per second I. And V average in the y direction is delta y divided by delta t, and that will be 4 meter divided by 5 second. That is 4/5 meter per second j. And therefore, V average, we write it like this: 6 over 5 meter per second I plus 4 over 5 meter per second j. Alright, I want you to now find the magnitude and direction of this. I have given you, this is the component form. Convert this to magnitude angle form. Tell me, what is the magnitude of this? The magnitude of that average velocity will be square root of x squared 6 over 5 squared plus 4 over 5 squared. I'm going to leave it for you to calculate. So the magnitude of the average velocity will be square root of x squared plus y squared. And what will be the angle of the resultant, the average velocity? The angle will be tan inverse of y over x. Tan inverse of 4 over 5 divided by 6 over 5. And that will be tan inverse of 4 over 6. Alright, find that angle on your own. You can express this in terms of magnitude angle form. Okay, let's look at another problem. At t equal to 0, a particle located at the origin has a velocity of 40 meter per second at an angle theta equal to 45 degrees. At t equal to 3 seconds, the particle is at x equal to 100 meter, y equal to 80 meter, and has a velocity of 30 meter per second at an angle theta equal to 50 degrees. Calculate A, the average velocity. Well, that's not different. That is not different from what we did. It is the same thing as we did last time. And calculate the average acceleration of the particle during this interval. Well, average acceleration is delta v divided by delta t. The change in velocity divided by the change in time. The difference here is that there is a change in velocity in the x direction and a change in velocity in the y direction. Therefore, you got to obtain each of those components of the acceleration. Alright, can you draw a diagram for this? You see, if you have to do a problem well, you need to picture that problem. Alright, let's draw a diagram. Where is the object at t equal to 0? At t equal to 0, the particle is located at where? At the origin. Yes, it's at 0, 0. So the particle at t equal to 0, it is at the origin, and it has a velocity of 40 meters per second directed at an angle 45 degrees. So it has a velocity 40 meters per second at an angle of 45 degrees. That means the car is moving in that direction. Well, and after 3 seconds, where is the car? It is at x equal to 100 meter, y equal to 80 meter. It is here. X equal to 100 meter, y equal to 80 meter. And at that time, what is its velocity? It has a velocity 30 meters per second. Its velocity is 30 meters per second at an angle 50 degrees. Alright, so now we have all this data. This is the velocity 30 meters per second. Alright, the initial position is 0I plus 0J, is the origin. The final position is 100 meter I plus 80 meter J, and therefore what is the change in the x position? The change in the x position is delta x equal to 100 meter I minus 0, and that will be 100 meter I, and that is the change in the x position. The change in the y position is 80 meter j minus 0j, and that will be 80 meter j. What is the average velocity? Average velocity is in the x direction. The average velocity in the x direction will be delta x divided by delta t, and that is delta x is 100 meter I divided by delta t is 3 seconds. That will be 33.3 meter per second I. What is the average y velocity? Will be delta y divided by delta t, and delta y is 80 meter j divided by 3 seconds, and that will be 26.7 meter per second j. Okay? Therefore, average velocity is 33.3 meter per second I plus 26.7 meter per second j. Alright, can you find the magnitude angle form of this? I haven't done it. I'm going to ask you to do that on your own. The magnitude of this average velocity will be square root of x squared plus y squared. I hope you understand when I say x and y. This is the x component, this is the y component. So the magnitude of the resultant is square root of x squared plus y squared. And the angle of the resultant, or the average velocity, will be theta equal to tan inverse of what? Y divided by x. Okay, let's move on and do the second part. Alright, now we have the velocity. We need to find the average acceleration. Is that right? What is the velocity at t equal to 0? The velocity at t equal to 0 is 40 meters per second at an angle 45 degrees. That means you need to write that in the component form. So the initial velocity at t equal to 0, we call it v sub 0 or v0, is 40 meter per second cos 45 degrees I plus 40 meter per second sine 45 degrees J. Now use your calculator to work out those numbers. That will be 28.3 meter per second I plus 28.3 meter per second J. Well, that is the velocity at the origin. Now, what is the velocity at t equal to 3 seconds? Or we can call it v of 3. Is that right? Yes. V of 3 is at t equal to 3 seconds. Its velocity is 30 meter per second at an angle 50 degrees. Therefore, the x component of that velocity is 30 meter per second cos 50 degrees I plus 30 meter per second sine 50 degrees J. And that is the component form of the velocity at t equal to 3 seconds. Again, use your calculator and find these numbers. Alright, are you working with me? Okay, that's equal to 19.3 meter per second I plus 23 meter per second J. Well, we know the velocity at t equal to 0. We know the velocity at t equal to 3. We can now find the change in velocity. For the change in velocity, there is a change in velocity in the x direction and a change in velocity in the y direction. Alright, let's do that now. Delta Vx, what does delta Vx stands for? The change in the x velocity. The change in the x velocity will be the final x velocity minus the initial x velocity will be 19.3 minus 28.3 I. That will be negative 9 meter per second I. That is the change in the x velocity. Alright, what is the change in the y velocity? The change in the y velocity will be the final y velocity minus the initial y velocity. 23 meter per second J minus 28.3 meter per second J, and that is negative 5.5 meter per second J. That is the change in velocity in the y direction. Now that means there is a change in velocity in the x direction. You can use this to find the acceleration in the x direction. So a sub x, what does a sub x stands for? Acceleration in the x direction is the change in velocity in the x direction divided by delta t, and delta Vx is negative 9 meter per second I, and delta t is 3 seconds, and so a sub x, the x component of the acceleration, is negative 3 meter per second squared I. What is ay? The average acceleration in the y direction is delta Vy divided by delta t. What is delta Vy? Is negative 5.5 meter per second J divided by delta t, and that will be negative 1.8 meter per second squared J. Alright, so we got the x component of the acceleration, we got the y component of the acceleration, and therefore the average acceleration is negative 3 meter per second squared I minus 1.8 meter per second squared J. Okay? Alright. Let's do